Welcome to our latest video. This video is on the topic of the extraction of aluminium using electrolysis, and this video is suitable for GCSE students. By the end of this video lesson, you should understand that aluminium can be extracted from its ore using electrolysis and be able to explain how this process works. You should also be able to name the products that form at each electrode and be able to write electrode equations to describe what is happening at each electrode. And finally, you should understand why the aluminium oxide, or alumina, is dissolved in molten cryolite and why the process is expensive. In previous lessons, we've discussed the relationship between the ease at which a metal can be extracted from a metal ore and its reactivity. And we've discovered that metals at the bottom of the reactivity series are the easiest to extract, and metals at the top of the reactivity series are the hardest to extract. This is because metals at the top of the reactivity series form the most stable compounds and require electricity to break down these compounds. Now, in this video lesson, we'll be focusing on one of these reactive metals, aluminium, and learning how it can be extracted from its ore using electrolysis. Aluminium is a much more reactive metal than people think. This is because when aluminium gets in contact with the air, it forms a tough layer of aluminium oxide, which protects the aluminium from further reactions. Now, aluminium is extracted from an ore called bauxite. And after mining and purifying this ore, you are left with a white solid of alumina, aluminium oxide. And this aluminium oxide is an ionic compound that conducts electricity when you melt it. And if we connect aluminium oxide up to electric current, we are able to break down the compound into aluminium and oxygen. And this process is called electrolysis. In our previous video on electrolysis, we explained how the process works in great detail. We will recap this in this video. However, if you are confident you understand how electrolysis works, you can skip this section of the video. We're now going to go through the theory of electrolysis. So, if you have a power pack or battery connected up to your two electrodes and that is dipped into an ionic compound that is molten or dissolved, that ionic compound conducts electricity and it can be broken down by the electricity. And the ionic compound consists of positive ions and negative ions. And when the power supply is turned on, electrons will flow onto the negative electrode, because remember, electricity is a flow of electrons, and positive metal ions are attracted to the negative electrode. So for example, if you had copper oxide, the Cu2 plus ions would be attracted to the negative electrode. When they're attracted to the negative electrode, they pick up electrons from this electrode and they use these electrons to form the metal. So copper 2 plus would gain 2 electrons to form copper metal. Now the negative electrode is called the cathode, and metals always form at the negative electrode. So copper 2 plus ions are attracted to the negative electrode, they pick up electrons from that electrode, they gain electrons, and they form a metal. And on that electrode you would see brown copper forming at this negative electrode. Now in ionic compounds, you don't just have positive ions, you have negative ions. And if this ionic compound is melted or dissolved in water, these negative ions can move about just like the positive ions. And the negative ions are attracted towards the positive electrode. Now we call the positive electrode the anode. And if we had, say, copper oxide or copper chloride, the oxide ions or the chloride ions would be attracted to the positive electrode. And when non-metal ions are attracted to the positive electrode, they form non-metals. So for example, the chloride ions would be attracted towards the positive electrode and would ultimately end up forming chlorine gas. And the oxide ions would move towards the positive electrode and ultimately form oxygen gas. Now, these negative ions, when they move towards the positive electrode, they lose electrons. Now, the reason that these negative ions have a negative charge is because they have more electrons than the corresponding atoms. For example, Cl- ions have one more electron than a Cl atom, and an O2- ion, an oxide ion, has 2 electrons more than the corresponding oxygen atom. So when these negative ions move towards the positive electrode, they lose these extra electrons to form non-metals. And these electrons then flow from the positive electrode to the power pack and complete the circuit. So you have to remember that metals form at the negative electrode, the cathode, and non-metals form at the positive electrode, the anode. This slide aims to reinforce the fact that metals form at the negative electrode, called the cathode, and non-metals form at the positive electrode, called the anode. And if you have molten aluminium oxide, melted aluminium oxide, your two products are aluminium, which forms at the negative electrode, and oxygen, which forms at the positive electrode. In our previous video, we've discussed how electrolysis can be carried out in a laboratory, and we've shown you the apparatus you would need to use to do this. The difference here is that we are producing aluminium on a large industrial scale. So the equipment that we would need will look very different to the equipment we would use in laboratory. However, the principles will be the same whether we're carrying out an electrolysis experiment in the laboratory or on an industrial scale. We will still need a source of electricity, we will still need electrodes, and we will still need a molten compound to break down into two products. This slide shows what the apparatus or equipment looks like in the industrial extraction of aluminium. You would have a steel tank, and this tank is lined with graphite, carbon, and it is negatively charged because this represents the negative electrode. It's the lining of the tank which is the negative electrode. Inside the tank, you place the molten compound you are trying to split up using electricity. And this is referred to as the electrolyte in an electrolysis experiment. And the electrolyte, in this case, is aluminium oxide. Now, aluminium oxide has a very high melting point. It melts around 2000 degrees C. And this would be very expensive to melt on a large scale. So we need to try and reduce the melting point to make it a more economically viable process. To do this, we add another ore of aluminium, cryolite. And this impurity makes the melting point lower. And by adding cryolite, we can bring the melting point of aluminium oxide down to around 900 degrees C, which makes the process a lot cheaper than it would be. And it means that this process is now economically viable. Now, the positive electrodes, the anodes, are also made of graphite, And these blocks, which represent the positive electrodes, these are placed in the electrolyte. These are placed in the aluminium oxide and cryolite mixture. And as current passes through the aluminium oxide, it is broken down into aluminium and oxygen. Now the aluminium forms on the bottom of the tank because the bottom of the tank has a lining which represents the negative electrode. So you would get liquid molten aluminium forming on the bottom of the tank. Now around the carbon blocks which represent the anodes, you will see bubbles of oxygen gas because the other product in the electrolysis of aluminium oxide is oxygen. Now if we want to get the aluminium from the tank, the aluminium is a liquid and the aluminium oxide and cryolite mixture is a liquid. So what happens is they siphon off the molten aluminium, and then this would go to various casts or molds to get aluminium in the shapes that you want. Now this slide summarizes the key points about this process. So first of all, we want you to be aware that aluminium oxide is an ionic compound, and the Al3+ ions and the O2- ions are attracted together in a giant structure. There are billions of these ions all stuck together in a giant structure with strong forces between the ions. And this means that it takes a huge amount of heat energy to melt aluminium oxide. Aluminium oxide has a melting point of around 2000 degrees C. Now, it would be too expensive to carry out electrolysis of molten aluminium oxide unless we were able to lower the melting point. And we lower the melting point by adding an impurity, by adding cryolite, another ore of aluminium. Now, when we add cryolite, the melting point of this mixture is now 900 degrees C. The fact that we're able to lower the melting point to around 900 degrees C makes the process economically viable. We're now able to carry out the experiment. It's still expensive, but it is economically viable to produce aluminium from an electrolysis experiment. The other thing that we want you to know is that the anode and the cathode are made of graphite, and graphite has a high melting point and is a good conductor of electricity. The lining of the tank represents the cathode. It is negatively charged and the tank is lined with carbon, it's lined with graphite, and that's where the molten aluminium forms. The positive electrodes sit inside the tank and it's oxygen that form at these electrodes. Now, in our previous video on electrolysis, we discussed how to write electrode equations to represent the formation of products at each electrode. Now, in this process, we have Al3+ ions being attracted to the negative electrode, the cathode. And when an Al3+ ion is attracted to the cathode, it gains 3 electrons and makes aluminium metal. Now, the reason that Al3+ ions are able to gain 3 electrons is because the 3+ charge indicates that it has 3 less electrons than an aluminium atom. Now, when Al3+ ions gain electrons, that is classed as a reduction reaction. Reduction, when talking about electrons, means a gain of electrons. Why is it called reduction when it means gain? This is because the charge on the aluminium goes from 3+ to 0. The charge has been reduced. Now, at the positive electrode, the anode, oxide ions are attracted. And oxide ions are attracted to the positive electrode because, remember, oxide ions have a negative charge, so they're attracted to the oppositely charged electrode. And when they move towards the positive electrode, they lose electrons to form oxygen gas. Now each oxide ion has a 2- charge, so it means it has 2 more electrons than an oxygen atom. So each oxide ion needs to lose 2 electrons to form an oxygen atom. However, oxygen exists as molecules, not atoms. So that's why 2 O2- ions needs to lose 4 electrons to form oxygen gas. Now sometimes you will see this equation written slightly differently. So instead of writing 2 O2- ions minus 4 electrons goes to O2, some people write this equation as 2 O2- arrow goes to O2 plus 4 electrons. They've just moved the electrons over to the other side of the equation. So similar to when you're doing a calculation in maths, if you move the 4 electrons over to the other side of the equation, it will change its sign. So it becomes plus 4 electrons. Either is absolutely fine, whichever you are more comfortable with, write that equation. Now the reason I prefer to write it as 2 O2- minus 4 electrons goes to O2 is because it helps me remember that this process is a loss of electrons. And the word that we use to describe a loss of electrons is oxidation. So at the negative electrode, we have reduction because the Al3+ ions gain electrons. And at the positive electrode, we have oxidation because the O2- ions lose electrons. Now this process is a very expensive process because huge amounts of electricity is needed to carry out electrolysis. And this means that aluminium factories or plants are nearly always built next to power stations. Wales had a major aluminium plant in Anglesey, and this plant, Anglesey Aluminium, was built next door to a nuclear power station. And when the nuclear power station was decommissioned and closed down, the aluminium plant was closed down as well, because you need a power source, a big power station next door to an aluminium plant, because it needs huge amounts of electricity to operate. Now at one stage, Anglesey Aluminium accounted for 10% of Wales's total electricity use. So that is the point I'm making. If you're going to produce aluminium from aluminium oxide by electrolysis, you need huge amounts of electricity. There are also 2 other reasons why the process is very expensive. The first of these is the fact that to melt aluminium oxide, even when you add cryolite to reduce its melting temperature, you still require around 900 degrees C to melt the aluminium oxide cryolite mixture. Now this requires a huge amount of heat energy, which means that the costs of operating this process are very high. Now the final reason that this process is expensive is down to the fact that the anodes need to be constantly replaced. Now the anodes are made of carbon, they're carbon blocks, they're made of graphite specifically, and in this process oxygen forms at the anodes. Now due to the high temperature and the fact that oxygen is forming, these carbon blocks get changed to carbon dioxide because the carbon reacts with the oxygen. And you've got a solid block representing the anode, and over time this block changes to oxygen gas. The anode disappears and you need to replace it. So this also makes the process quite expensive. Now because aluminium is such an expensive metal to extract from its ore, there is a real need for us to recycle aluminium. Now when you recycle any metal, you save money because it's nearly always cheaper to recycle a metal than make it from scratch by extracting it from its ore. You're also saving lots and lots of energy if you recycle metals as opposed to making them from scratch by extracting from their ores. And you will save heat energy and electrical energy if you recycle aluminium as opposed to doing this process. Recycling aluminium uses only about 5% of the energy needed to extract it from bauxite. Cutting down on the amount of energy we use, reducing our energy consumption, is important for our planet because we'll end up using less fossil fuels if we do this, and therefore there'll be less greenhouse emissions and we will be reducing the effects of climate change. Recycling metals also reduces the amount of raw materials that you're using. In the case of aluminium, we get aluminium from aluminium ore, bauxite, and if we can recycle aluminium, we cut down on the amount of this ore that we're using. And currently bauxite is the only aluminium ore that we can extract aluminium from. So if we want to have aluminium in the future, it's important that we preserve this resource and cut down on the amount of aluminium ore that we're using. Now, aluminium is not the only metal that is recycled. For example, steel is also recycled on a large scale, and recycling steel saves 50% of the energy used in the extraction of iron. It helps to conserve iron ore and also cuts down on the emission of greenhouse gases. So recycling is very important for the environment. So now that we've discussed how aluminium can be extracted from its ore, we're going to finish by focusing on the properties and uses of aluminium. So aluminium is a typical metal in the fact that it conducts electricity, it conducts heat, it's got a high melting point, it's malleable, which means we can hammer it into different shapes, it's ductile, which means it can be drawn into wires, and it's got a low density as well, which is very useful. Now, the uses of aluminium, like all metals, depend on their properties, and you will have to suggest the properties that make aluminium suitable for certain uses. So, for example, aluminium is used in saucepans because it's a good conductor of heat. It's also got a high melting point. That's why it's suitable for saucepans. Aluminium is used in drinks cans because it's malleable. It can be hammered into different shapes. Aluminium is used in overhead power cables because it's a good conductor of electricity. And in addition to that, aluminium is also light, it's got a low density, and doesn't rust. The fact that aluminium doesn't rust or corrode is the reason why it's used in window frames. And the fact that aluminium has a low density is also important in its use in aeroplanes. So you have to be able to link the use of aluminium to its properties, and many exam questions will ask you to do this. So now let's test your understanding of the topics we've covered in this video. So you're going to be shown a series of exam questions, pause the video, have a go at the questions, and then we'll go through the answers. So here's our first exam question, and this comes in 3 parts, A, B and C. Part A is on this first slide, so read through the question, pause the video and have a go at it. Now here are questions B and C. Read through the questions, pause the video, have a go at the question, and then we'll go through the answers. So now let's see how you got on with question 1, and we're going to look at 1A first. So the formula of the ions present in molten aluminium oxide is Al3+, aluminium, and O2-, the oxide ion, and there's 1 mark for each. And then the reason that aluminium forms the negative electrode is that the Al3+ ions are attracted to the negative electrode and they gain electrons to form aluminium. So there's a mark for this. And then it asks you why the process is expensive, and it's because lots of electrical energy and lots of heat energy is needed. Either would be okay. You could either say lots of electrical energy or lots of heat energy needed, and that's why it's an expensive process. Yes, it's also expensive because you have to replace the anodes, but the major reason why it's expensive is the huge amount of energy needed, both electrical and heat energy. So 1 mark if you mentioned either of those. So now let's look at the answers to B and C. So B is asking you to name another factor apart from an available workforce or transport systems, distance from built-up area, which are considered when locating a new chemical plant. Well, one factor you could say is near a power station, because I've mentioned this already, that you need to have it near a power station because of the huge amounts of energy that you need for this process. You could also say it needs to be near a port because you need to import aluminium ore and you also need to export aluminium. So those two would be other factors that you could consider when locating a new aluminium extraction plant. And then ask you why aluminium is used in overhead power cables and the properties that make it suitable. So you'd go for conduct electricity, you could go for low density, you could say it's ductile, and you could say it doesn't rust. Any of them would be fine, and there's 1 mark for each of those. So here's a second question we'd like to have a go at. So we're asking why cryolite is added to the aluminium oxide. We want to know which electrode does the aluminium metal form, at which electrode does oxygen gas form, and we want you to write electrode equations to represent the formation of products at each electrode. Pause the video, have a go at this question, and then we'll go through the answers. So now let's see how you got on with question 2. So the reason that they add cryolite is to lower the melting point, 1 mark if you got that idea across, and by lowering the melting point you save energy, which reduces costs. So if you said save energy and this reduces the costs, or just said save energy, I would give you the 2nd mark. Then asking which electrode does aluminium metal form, it's the negative electrode called the cathode, 1 mark for that. And then it asks you which electrode does oxygen gas form, that's the anode, the positive electrode, 1 mark for that. Now finally for part D, you're asked to write electrode equations to represent the formation of products at each electrode. So you would have Al3 plus 3 electrons goes to Al, that's what happens at the cathode, and you would have 2 O2 minus ions minus 4 electrons goes to O2, that's what happens at the anode. And you could write the anode equation as 2 O2 minus goes to O2 plus 4 electrons. Either is okay. There's 1 mark for each correct electrode equation. So here's the final question we'd like you to have a go at. So pause the video, read through the question, have a go at it, and then we'll go through the answers. So now let's go for the answers to question 3. So reduction is a gain of electrons, 1 mark for that. In part B, you're asked to explain what oxidation is. Well, oxidation is a loss of electrons, there's 1 mark for that. In part C, you're asked to explain why the anodes have to be replaced regularly. So if you say that they wear away or they disappear over time, there's 1 mark for that. And if you explain why they wear away and disappear by the carbon anodes turning to carbon dioxide gas because of the oxygen being made, you get the 2nd mark. And for part D, suggest an environmental problem caused by the electrolysis of aluminium oxide. Well, in this process you use lots and lots of energy, and energy is often produced by fossil fuels, so therefore we would accept global warming or climate change, and even I would accept acid rain here, because burning fossil fuels can cause acid rain, and if you're producing lots of energy and you're reliant on fossil fuels, that would be another environmental problem. So that concludes this video lesson. So after watching this video, you should now understand that aluminium can be extracted from its ore using electrolysis, and you should be able to explain how this process works. You should also be able to name the products that form at each electrode and be able to write electrode equations to describe what is happening at each electrode. And finally, you should understand why the aluminium oxide is dissolved in molten cryolite and why the process is expensive. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.